Hey, this is Amanda Suri. I'm going to show you my diagram of a sarcomere. So here we have a representation of a sarcomere. The tiny green straws resemble thin filaments, and then the Q-tip chopsticks are the thick filaments. So first we're going to go through a little bit of description of the thin and the thick filaments. The thick filaments are connected in the middle along the M line. They are comprised of myosin, and they have these myosin heads that are called cross bridges that are actually going to interact with the thin filament. The thin filament are these green straws, and they are made up of actin. Here I created sort of a closer look of a thin filament by drawing the green part is the tropomyosin. That's going to cover up the binding sites for the myosin heads. And then these little orange nubbins, that's troponin, which is what the calcium ions are going to bind to enact muscle contraction. The troponin is attached to the tropomyosin. So, calcium enters, it's released by the sarcoplasmic reticulum into the sarcoplasm. That's after when an action potential is generated by a motor neuron. A motor neuron is propagated on the muscle cell surface. So calcium gets released, and then it binds to the troponin, the little orange sites on the thin filament. The troponin changes shape, and then it pulls the tropomyosin off of the active sites, and then the myosin heads latch on, and then they swivel, and then the thin moves past the thick filament. So it's not shortening, it's just overlapping. So by this point, when the sarcomere wants to unbind, we need ADP. So the myosin heads release ADP in the thick filament, and that breaks the connection between the thin and the thick, and then it returns to the original state. And then the ADPase pump actually reabsorbs the ADP back into the sarcoplasmic reticulum. So that's the sarcomere. Thank you.